Right now we're nearly at the end of our stoichiometry. I'm down here, let me just show you. I've asked you already now, please, will you put in that insertion, excess reagents as number 6. I'm about to do number 7. We'll know that as percentage yield. Now, let's get the jargon right so that when you're reading a question, you know what you're being asked. Have they asked you for reacting masses, the mole strip? Okay, full equation, one quantity, construct your mole strip, away you go. Have they given you a full equation and 2 quantities? In which case, they show me that this is an excess. You immediately have the limiting reagent, you set up your mole strip and you have a standard method for that, and now we're doing percentage yield. These 2 are often integrated, these 3 could be integrated together, and I'm going to do one example of this with you. Now, can I start by saying a few things to you? From your notes, you will know already that you need to have some sense of what percentage yield means. The amount or the mass of the product formed in a chemical reaction is called the yield. The amount of product is called the yield. If we assume a reaction goes to completion, then the chemical equation allows us to calculate the theoretical yield. Now, the theoretical yield, I'll talk to you in more detail about in a moment, but that's fine. Very few reactions go to completion in practice. You'll find all sorts of things happen. Murphy's Law generally, bits get spilt, parts of the product escape, temperature wasn't right or whatever, and therefore, in practice, very few reactions go to completion. The yield obtained in the laboratory is called the actual yield. And of course, you'll need to know the formula for percentage yield more than anything else. The percentage yield is equal to the actual yield over the theoretical yield multiplied by 100. That's very important now. That the percentage yield is the actual yield over the theoretical yield by 100. And here's how you go about it then. Let me just tell you this. The theoretical yield will be got from the mole strip. Okay, you'll have to do a calculation to get the theoretical yield. The actual yield is very likely going to be given to you in the question. And consequently, you calculate the percentage yield. Are you okay with that? I'm saying that again to you now. The percentage yield is the actual yield over the theoretical yield multiplied by 100. The theoretical yield will have to be calculated based on the balanced equation and the data given. You'll have to go and get the theoretical yield from the mole strip. I'll show you how to do that. They will probably give you the actual yield and then you'll go and do your calculation. But wait a moment. They could give you the actual yield. They could give you the theoretical, they could give you the percentage yield, They give you the percentage yield. They could give you, you could calculate the theoretical yield and you could be asked to find the actual yield. Are you clear? 3 variables there. They could give you any 2. Just be alert to that now to come up with something different. They could give you the percentage yield. You'd use your mole strip to get the theoretical yield and you could find out how much was actually produced by the student. Now, that's rather important that you have a sense of that because we'll be using that over and over again, and it will be important that you'd have an awareness of where we're going with that. Okay, so I'm going to put up a question here which is intricate enough in that it integrates 2 parts. The first part is about the excess of it, and the second part then is the percentage yield, and we need to work our way through that. Now, this is the one I alluded to a while ago. I hadn't got there yet, but I'd alluded to it. This is in your notes, this particular question. Okay, I'll read it for you, but it's in your notes anyway. A student prepared ethanol by reaction between acidified sodium dichromate and ethanol. The quantities used were 17.88 grams of sodium dichromate, and they give you the molecular formula, by the way. They give you the molecular formula, be careful, and 11.04 grams of ethanol. At the end of the experiment, the yield of ethanol was found to be 2.97. That's the actual yield, okay, given in the question. They may not use the word yield at all. They may say something like, when the student had isolated the product and weighed it, it had a mass of 2.97. You'll always know that's the actual yield as distinct from the theoretical one, okay? The equation for the reaction is given to you and they ask you 2 questions. The first question they ask you is to show that ethanol is in excess. That's the first one. Is the ethanol in excess? Very important that you're aware of that, okay? And if you are, you're fine. Now, I'm dealing with them in sequence. I'll do it that way. First of all, the excess one. Do you know the rules for showing something as an excess? You're given a full balanced chemical equation and you're asked to show that ethanol is an excess. So if ethanol is an excess, then that's the limiting reagent. That would apply to any equation. If they said show that this is in excess, it means the other one is the limiting reagent. So showing one is the limiting reagent, you automatically show the other, and that'll be fine. Now, what are the rules for showing something as an excess? Take the two quantities they gave you and convert them to moles. Now, this was generous enough in that they both came as grams. Will you remember one of them could be a solution, in which case you'd need your friend. Now watch out for that, we met it already. I can't guarantee you they're always in grams, both of them are in grams there, that's fine. So you convert the two quantities to moles. Step number 2, you construct the mole strip, which is what I'm going to do for you now. I'm going to do that, okay? We must take the full equation. C2H5OH plus Cr2O7 2 minus plus 8H plus there goes to 3CH3CHO plus chromium ions, there's 2 of them there, and you have 7 water. It is very important you get it all under one line. Will you be careful, please? And I need a 3 here, and I need a 1 here, and I need an 8 there. 3, 1, 8, 3, 2, 7. Will you be very careful you're taking it down correctly? Good. Now, they asked to show that ethanol is an excess. So this guy must be the limiting reagent. Very good, the limiting reagent. Now, will you be very careful here, please? Dichromate. If you were to divide that by the MR for that, you'd make a serious mistake. The dichromate, they gave you the full formula here. You must include the 2 waters and the full molecular formula, 298. Now that's very common. When they write equations, they often put in the active ion and they leave all the spectators out. So consequently, will you be careful with that? You can't use that, you have to use the original formula. Or I'll put it another way to you, they didn't give you that unless there was a reason. They gave you that, the minute you see that printed after a name, I'm going to need that for the relative molecular mass, that's very important. Right, good. So that's the limiting reagent, so that's the one we have to look at, the dichromate. Okay, so what did you have there? You had 17.88 grams. Okay, of that, I'm checking that's right. Now, the ratio strip, 3, 1, 8, 3, 2, 7. Now, let me mention something here about reactants for a moment. There are 3 reactants here. Will you take it generally that you won't have equations with 3 reactants? That's a reactant, and that's a condition. In other words, that reaction won't take place unless the medium is acidic, and the H pluses represent that, and that's all there is to that. There'll be nothing more to it, right? So just keep it like that, you'll be fine, okay? But just take it, they're the 2 competitors, right? The excess, they gave you 2 quantities. They're the 2 competitors. One is an excess, and one is a limiting reagent, right? That's the boss, so that's the one that will dictate the moles strip. Okay, so you convert that to moles, you have it done there already. Okay, 0.06. That's 0.06, that'll be 0.18. That there, we want to work through that, it's going to be 0.48. That one here is going to be 3 there, 3 times that, 0.18. And if you want to put in the others, you can. Now I'm going to explain to you in a moment, you won't need all of these, but you could in different circumstances. That's 0.12, and that's 7 times that, 0.42, very good. And there's the mole strip, okay, very good. Now, do you remember how you were doing this? Show that ethanol is an excess. You're given 2 quantities and a balanced equation. Convert the 2 quantities to moles, we've it done, okay? Now next, construct a mole strip. You cannot construct a mole strip if you don't know the limiting reagent. It dictates everything. If that number is wrong, a horror story. I've warned you about that already now, that people would divide by the wrong MR here. They'd only take that when they should have taken this. That would be very serious now, because that number would be wrong, this would be incorrect, and the entire strip would be wrong. Now, that's the downside of the mole strip. You need to be very alert that you have your numbers right, okay? Very good. Now, where are we going from here? You have constructed a mole strip, and the third step was, I'm reading again now, convert the 2 quantities to moles. Okay, we've done there. Next, construct the mole strip. I've that done. Next, use the mole strip, to determine how much of the excess reagent is actually used. And there it is. Okay, and that's very important. And you're going to say 0.18 moles of C2H5OH is used, is consumed, is reacted. All those words are fine, yeah? But you're supplied with 0.24 moles of that is supplied. You're supplied with more than you need, so it's in excess, okay? That's good. Ethanol is in excess, that's it. You'd write that out now. You'd write that out as words now, please. You'd say, but this is supplied, therefore you're supplied with more than you need, and therefore it's in excess. Are you okay? And you do that every time. 3 steps for the last time then is, you'll be given a full balanced chemical equation and 2 quantities. Convert the 2 quantities to moles. Next, construct the mole strip. You cannot construct the mole strip if you don't know the limiting reagent. They'll have alluded to it in the question. Now they might ask you which is the limiting reagent, or which is the excess one. And I told you what to do. The ratio is 3 to 1. Work out the number of moles of one of them. There you are. And that's okay. And you say, okay, for every 0.06 of that, I need 0.18 of that, and I'm supplied with more, so it's in excess. Or the other way around, work out the number of moles of the alcohol. The alcohol is there, okay, and you have 0.24 moles. You have 0.24 of that, so you'd have 0.24. A third of that, okay, is 0.8. You'll be working with that. Are you okay? As I have it there, 0.24. You can work in reverse and get that. One will be shown to be greater than the other. Okay, and once you've got one, you have the other. If you know the limiting reagent, you know the excess reagent. If you know the excess reagent, then you know the limiting reagent. And that's the way you'd be working with that. Just be careful with it as to what they're doing. Now, that's only the first half of the question, and that's not all the question, but that was one part of it. Show it was in excess, and you've done that. The second part of the question I want to focus on now. Calculate the percentage yield. Okay, calculate the percentage yield. Now, this isn't too bad at all. You'll find this relatively easy to deal with. You're back to your mole strip for this. Now, this was an experiment to prepare ethanol. They'll tell you that somewhere in the question. A student prepared ethanol. Okay, so there is your product. And the yield refers to that. Now, straight away, that is the theoretical yield. Before you do anything else, that's the theoretical yield. Okay, so the theoretical yield is equal to 0.18 moles, which is 0.18 multiplied by, you have the AMR for that, we'd have to work out to give you that, and you can work with that then, it'll be fine. Okay, I'll just give you values for it so we can deal with it. I think I have it somewhere here. You multiply by 44, and you're going to get 7.92 grams. That's the theoretical yield. So the percentage yield is equal to the actual yield, back to the question. The actual yield, 2.97 over the theoretical yield, 7.92 multiplied by 100. Okay, and that's what you're working with there, and that comes out to be 37.5% yield. Okay, so in other words, we seem to have lost about 60% of the product. And that's not going to arise here, but the reasons why you lose it could be many. But what you want in this particular case more than anything else, and I would say to you now, you need to be careful, is that that's a volatile liquid. It vaporizes very easily. So to escape out of the flask as quickly as you're making it, you'd probably have to collect that in an ice bath. You'd have to wrap the flask in ice to keep the temperature down so it wouldn't volatilize, and that's rather important. Now, that's a unit in itself. I don't really want to give it too much time because I think you'll be fine with it in what you're actually doing, but it comes out to be 37.5%. Okay, now I'd prefer you use the mole strip to get your theoretical yield. I'm stressing to you now, that's the theoretical yield. Now, as it happens in this question, you never needed that, or you never needed that. But in another year, they might just have said at the end of this, what mass of water was produced in this reaction? So you Go to there, multiply by the MR. They could ask you, okay, how many ions, chromium ions, were produced in the reaction. Number of moles multiplied by Avogadro's number. Okay, so whereas you don't always need all of the mole strip, it's as well off to do it and to be ready for that just in what you're doing. Now, I'm going to leave it at that. Can I say to you now, please, that I am now in a position to go through your exam paper with you. And in the next video, I want you all to have that exam paper in front of you, and I'll go right through all 5 questions, and you'll be falling over the mole, percentage yields, and of course, a bit on your volumetric as well. So it is very important you prepare that now, and that you come back ready to do that when you've all this revised. And I'll be taking you from there, I suspect, into oxidation and reduction would be our next direction then. And you'll be getting notes on that in due course. All right. So let's just get that together now first, and we'll do the exam next.